This is Thermochemistry Part 7. Here we'll be looking at doing heat of reaction calculations, which we'll call thermal stoichiometry. So once again, heat of reaction is the heat released or absorbed during a chemical reaction. And we're going to look at this reaction right here, and we're going to calculate how many kilojoules of energy are produced by burning 821 grams of methane with excess oxygen. So let's take a look at this right here and how we should interpret it. What this 890.4 kilojoules tells us is that 890.4 kilojoules is produced for every 1 mole of CH4. That's methane, natural gas. Now, what this also tells us is that 890.4 kilojoules is produced for every 2 moles of O2 that we react with. Likewise, it's 890.4 kilojoules are produced for every mole of CO2, or every 890.4 kilojoules for 2 moles of H2O. We're going to work these just like stoichiometry problems, and we're going to treat this like a coefficient. So let's see how this works. Our given is 821 grams of methane. Our find is kilojoules of energy. So we're given this, and we want to find that. So we're going to start with 821 grams of methane. We need to get over to moles of methane, or we cannot use this conversion factor. So we're going to bring grams of methane down and moles of methane up. So for every 1 mole of methane, using our periodic table, we have 16.04 grams of methane. So now we're to moles of methane, so we'll be able to use this right here. Or we can go back to the balanced equation here. And so we have kilojoules to the top. We have moles of methane in the denominator. This says we have 890.4 for every 1 mole of methane. Let's highlight this so that you can track what it is that I am talking about. And let's use kind of a nice pink there. All right. So we took the 890.4, 890.4. Let's use kind of a nice bright green. Okay, we had 1 mole, 1 mole. So we just go back to the balanced chemical equation. Let's try another one. So we're going to come down here. So we're using the same equation, different question. How many liters of oxygen would be consumed to produce 122 kilojoules of heat in the below reaction? And I forgot to say at STP. Because remember, at STP, we've got 22.4 liters equals 1 mole of a gas. That's a nice, useful thing to remember. So I've specified that it's going to be at STP. All right, let's start off with the given. Our given is 122 kilojoules of heat. And our find, we want to know liters of O2 gas. So it's going to be liters of O2. Remember, go back to your equation to make sure that if they say oxygen, it says O2, that's the form you're going to use. So let's go ahead and start it off. We have 122 kilojoules. We need to get out of kilojoules over to moles of O2, which we can do. go using the balanced equation. Here we have 890.4 kilojoules. 890.4. And this time we've got 2 moles of O2. All right, we're trying to get to liters of O2. We've gotten to moles, so we've got to get out of moles of O2. And we're going to get to liters of O2. We're at STP, so if we have 1 mole of any gas, and O2 is a gas, then we're going to have 22.4 liters. So you're going to go ahead and plug everything in and solve, and you're going to get 6.14 liters of O2. Put a box around it so I know you're done. And I'm sorry, I forgot to solve this one. Let's come back in. You should have plugged everything in, and you would have gotten 45,600, that's a comma, kilojoules. Put a box around it so I know you're done. Okay, let's come back here, and we're going to color code so you can see where I got everything. So let's go back to the highlight tool, and we're going to do the kilojoules first. So we had, there's our kilojoules, there's our kilojoules, so straight off the balanced equation. And then we were looking at O2, so we took the coefficient from the balanced equation down. So you see you're treating the value here just like a coefficient, and this is a coefficient, and you're doing it just like stoichiometry. Here are some practice problems for you to try. I've written the answers down right here so you can make sure that you're on track. What I'd like you to do now is stop the recording, try the problems, then turn it back on to make sure you have gotten the correct answers. Okay, here are the final answers. You can check your work, make sure you're understanding this clearly, and this is the end of this section.